Section 3.2, to use radian measure to find arc length and area of a sector. The next slide gives us a diagram similar to section 3.1. Here I have a central angle generated at the origin of a coordinate plane. It shows a radius that is equal to r and an intercepted arc of that angle that is also equal to the radius. Therefore, it is r. When the intercepted arc and the radius are congruent, that generates 1 radian. 1 radian equals the measure of the intercepted arc divided by the measure of the radius. And when they are equal, that generates 1 radian. Here, they're going to define this very similar to that, but they're not going to tell us that the intercepted arc is equal to r. They're going to say the intercepted arc is equal to s. And that arc length, which is here, is the measure of the arc intercepted on a circle of radius r by a central angle of measuring theta. Radians is given by the product of the radius and the radian measure of the angle. Or in other words, they show us s equals r theta. That is given by this equation, but now they're telling us that r can be any measure of s. So actually, all they did was take this function and say, I don't know that it's 1 radian, so this angle theta can be any measure. And the function generated by this is actually s over r. And to go from this function to this, what they're calling the arc length, which is s equal to r theta, is just multiplying both sides by r. The key to actually doing all this is to making sure that no matter what angle measure I have, it needs to be in radian measure. So if they give it to us in degrees, I need to convert that to radian. Let's look at our first example. A circle has a radius of 18.2 centimeters. Find the length of the arc intercepted by a central angle having each of the following measures. So in these two examples, my radius is going to be 18.2. I'm just going to change theta. From the previous slide, it tells us that theta has to be in terms of radians. On the first part here, it is in radians. So all I need to do is use the formula s equals r theta and substitute in my known values. Here, r is 18.2, and my radian for theta is 3 pi over 8. I substitute this expression into my calculator, and I get a value for the arc length to be 21.4 centimeters. Example 2 gives us an angle of theta to be 144 degrees. I first need to convert this into radians. So I'm going to multiply this by pi over 180. And when I do that, that's going to give me a radian measure equal to 4 pi over 5. Now I substitute into my formula. S equals r theta. My radius is 18.2 centimeters, and my theta is 4 pi over 5. Now I just substitute my expression into the calculator, and I'm going to get, from my arc length, 45.7 centimeters. The next example for arc length has a rope being wound around a drum with a radius of 0.8725 feet. How much rope will be wound around the drum if the drum is rotated through an angle of 39.72 degrees? This problem sounds more difficult, but it's just like the previous example. We are still finding arc length. This time the arc length is the length of the rope. Let's start by converting our given angle measure, which is 39.72 degrees, into radians. So theta is going to equal 39.72 times pi over 180. Now I substitute that expression into the calculator, and I get 0.693 radians. Now all I need to do is substitute that into my formula of S equals r theta. R is going to equal 0.8725 feet times 0.693 radians. When I substitute that expression into the calculator, I'm going to get 0.6046 feet for the arc length. Let's look at another example involving our formula S equals R theta. In this situation, we have two gears that are adjusted so that the smaller gear drives the larger one as shown. If the smaller gear rotates through 225 degrees, through how many degrees will the larger gear rotate? Well, let's start with our formula S equals R theta. Here, S is going to be the intercepted arc, or the length of the segment on the circle that this rotates. The degree is going to be in radians. We can convert that. Is the number of degrees that this gear actually rotates and this gear actually rotates. And R, we of course know, is the radius of the gears. We are given information about the smaller gear, that this gear rotates 225 degrees, and when I know that the radius is 2.5 centimeters, I can find the arc length that this rotates. The one thing that we do know about this situation is these gears are interlocked. When this gear rotates a certain number of inches by arc length, this gear will also rotate the same distance for arc length, but this gear will rotate a smaller number of degrees because of the size of the actual gear. So what correlates between these two gears is the congruence of arc length as one rotates and the other rotates because they are joined. So the procedure to follow here is to find the arc length that this rotates at 225 degrees with 2.5 centimeters. Then we can set the arc length equal to this gear and radius and solve for theta, which would give us how many degrees will the larger gear rotate. So the first thing we need to do, as specified from a couple slides back, is we need to convert 225 degrees into radians. The procedure for radians, 225 degrees times pi over 180. And when we simplify, our radians is going to be 5 pi over 4. Now, let's substitute into our equation and find the arc length for both gears. R, for the smaller gear, is 2.5 centimeters times the radians that gear is going to rotate is going to be 5 pi over 4. And when I simplify that expression, the arc length for the smaller gear is going to be 25 pi over 8 centimeters. But as stated previously, the distance that this gear rotates on the outer edge, or the intercepted arc, is 25 pi over 8 centimeters. That's also the distance that the larger gear rotates. So we can still use this formula to find measurements for the other gear. So let's substitute in what we know. We know S equals R theta, and we know what S is for the larger gear. It's congruent to the smaller gear. So S is 25 pi over 8. And we also know that R for the larger gear is 4.8 centimeters, and what we're trying to find is theta. The easiest way to continue is to convert 4.8 into a fraction. Remember, 4.8 is going to be 4 8/10. We simplify by dividing by 2, gives us 4 4/5, and then place into an improper fraction. So now we have 25 pi over 8 equals 24/5 theta. And to solve this, I'm just going to multiply both sides by 5 over 24, which gives us 125 over 192 pi radians for theta. That is the radian measure that this gear rotates to equal the same intercepted arc that the small gear rotates. But if we take a look back in the problem, it actually asks us to find how many degrees that gear rotates. We have this in terms of radians. So what we need to do is to convert that into degrees. So 125 pi over 192 times 180 over pi. The pi's will simplify out, and when I substitute into a calculator, I'm going to get approximately 117 degrees. Let's look at another example. Reno, Nevada is approximately due north of Los Angeles. The latitude of Reno is 40 degrees north, while that of Los Angeles is 34 degrees north. The N in 34 degrees means north of the equator. The radius of the Earth is 6,400 kilometers. Find the north-south distance between the two cities. Here we know that Reno is 40 degrees north of the equator. So the angle given is to be 40 degrees north for Reno. And the angle given for Los Angeles is 34 degrees north. So what we still want to use here is our formula for S equals R theta. In this example, we know that R is going to be the radius of the Earth, which is 6,400 kilometers. But in this situation, we are given two thetas. We are given 40 degrees for Reno and 34 degrees for Los Angeles. And what we want to do is find the distance in between these two. So what we need is the angle generated between those 2 degrees. So all we need to do is subtract these two values from each other, and what I end up with is a 6-degree difference between the two cities. Then I can substitute those values into our formula and find out what the intercepted arc length is on a 6-degree angle, and that would give me the distance between the two cities. But recall from previous slides, the first thing I need to do is actually convert 6 degrees into radians. So 6 times pi over 180 is going to give me pi over 30 radians for the angle measure. Now, all I need to do is substitute that and my radius into my equation, and I can find the arc length, or the distance between the two cities. Radius, 6,400 kilometers, and the theta for my difference in degrees is going to be pi over 30. If I substitute this into a calculator and calculate, I'm going to get 670.2 kilometers between Reno and Los Angeles.